Hello, we are Intelligence Incorporated. I am Albert Moreland.
My name is Stefan Hall.
Anna Alexander.
Major Swartz.
Cody Copenhagen.
And this is our presentation on the AI-1 Smart Shuttle. The AI-1 Smart Shuttle is a completely autonomous spacecraft. It requires no human intervention or control to complete its task. It takes off and lands on a runway, and allowing it to complete multiple missions within its lifespan, and is aided by special sensors for takeoff and landing. In order to understand the innovation and design of the AI-1 Smart Shuttle, it is necessary to have a working knowledge of existing technology, particularly in the fields of artificial intelligence and aviation. Advances in artificial intelligence have been at the forefront of computer science for quite some time. The purpose of artificial intelligence is to mimic the response of a typical human to various situations. However, a computer is only capable of executing predefined responses to a given stimulus. Contrary to appearances, a computer cannot think the way humans can. However, it is possible for a computer to learn from its mistakes by saving the incorrect response and not doing that again. Artificial intelligence is commonly applied to the field of aviation through the use of unmanned aerial vehicles, also referred to as drones. Though these drones are often controlled by a human at a computer, artificial intelligence programs are commonly used to control the flight of these aircraft. It is rare, though, for artificial intelligence to be directly involved in the landing of drones, as this is part of the flight carries the largest risk to the damage of an aircraft, and therefore human control is considered preferable. Wait, there.
Okay. Sorry. NASA's 5 space shuttles, first designed to be reusable in 1981, have since followed the same outdated design conventions. The shuttles take off vertically, carry out their mission, and return to Earth much like airplanes, landing horizontally on an ordinary runway. Due to this stagnation of the design, it is still common practice to lose billions of dollars in resources due to the one-time use of materials on space shuttles. For instance, the Apollo command module used materials that melted and fell away layer by layer during re-entry, reducing the ACM to a one-time only resource. The shuttles have exponentially decreased the space program's expenditure by utilizing insulating materials designed to last 100 re-entries before expiring, but even they lose valuable parts during the launch process. Each shuttle loses the entire external fuel tank, ejecting it once in orbit and causing it to disintegrate upon re-entry. What we hope to do with the AI-1 Smart Shuttle is make every piece of material safe for multiple uses. This includes housing fuel and lightweight piping throughout the shuttle that will take advantage of the space freed due to the lack of crew quarters, making external fuel tanks obsolete. We will also focus on developing a longer-lasting insulation material, preferably one that lasts the lifetime of the shuttle itself.
Now, on the topic of a vertical takeoff, it's not conventional for a spacecraft to take off on a runway, and it's an idea that hasn't really been tossed around too much over the years. It has not been attempted for a variety of reasons, but will prove much more cost-effective than the conventional vertical takeoff that is currently utilized. Vertical takeoffs utilize a variety of stages, and as Anna stated, dump millions of dollars of equipment during the launch. A horizontal takeoff would have one vehicle that would fly like an airplane off a runway and bring itself to supersonic speeds and move out of the atmosphere. This will require the vehicle that is more aerodynamic and capable of providing more lift than the conventional space shuttle that was previously used.
Goodrich Corporation is one of the largest suppliers of landing gear in the world. We can use this technology to have a stable landing gear which could consolidate our takeoff and landing. By combining the instrument landing system and the automatic carrier landing system, we can really complete the unmanned aerial vehicle. ILS is the ground-based instrument approach system that provides precision guidance to an aircraft landing on a runway with radio signals and high-intensity lighting arrays. This system enables a safe landing during low ceilings or reduced visibility due to fog, rain, or blowing snow. Automatic carrier landing system would ensure a safe landing by giving data link to intercept and log onto the landing pattern and establish a proper glide path. The autopilot would provide warnings if the automatic carrier landing mode becomes uncoupled or is degraded. On top of that, we can use We can also have a remote sensing function that are controlled by electromagnetic spectrum sensors, gamma ray sensor, biological sensor, or chemical sensors.
Current technological limitations in our capacity for unmanned spaceflight create tremendous inefficiencies that must be addressed as we move into a future in which space travel and exploration become increasingly important both as scientific necessities and as economic engines. First and foremost among these inefficiencies is the absence of a practical model for the transportation of people and goods to and from space that is reusable. This lack of reusability creates an inordinate amount of waste that makes such a vital endeavor into a prohibitively costly misuse of resources. This problem of resources necessitates the creation of a fully automated and completely reusable model for this kind of transportation.
The importance of the AI-1 Smart Shuttle is that we do need, will mainly consist of cargo space due to its intended use as a freight shuttle. Through the design of the shuttle will differ greatly from the shuttles recently retired, its purpose will be relatively similar. We intend to use the AI-1SS to transport and recover satellites, send supplies to the ISS, host experiments done in microgravity, and carry equipment needed by those working on the ISS. We will not use the shuttle to transport people, and the space normally used to house them on flights will be dedicated to the cargo and fuel holds respectively. With more space available, larger shipments can be made, reducing the overall number of trips needed annually.
By removing the man from the spacecraft, a large portion of space is freed up. This allows for the removal of the cockpit, food and water supplies, and functioning living quarters. The weight and space that is lost by removing these allows for a lighter vehicle and therefore improved performance during takeoff and landing.
Our craft's design will consist of three major portions, all familiar parts of a space shuttle but slightly revised. While a conventional space shuttle has an orbiter which houses the crew, we will redesign this portion to hold cargo such as satellite supplies and experiments to be tested in microgravity. The shuttle itself will be slightly smaller than the shuttles of history, but will remain relatively large in order to contain the necessary fuel without the use of an external tank. Fuel will be housed in lightweight piping throughout the interior of the shuttle, as well as contained in a compartment specifically for that purpose, towards the middle of the craft. Finally, our third component is the control room located at the front of the craft. This compartment will contain the brain of the craft, including the AI, programming, and engine systems.
The AI-1 Smart Shuttle is designed to be completely automated. There is not a single human involved from the moment the shuttle leaves the ground till the moment it lands again. The takeoff, docking with the ISS, and landing of the spacecraft is all handled by an onboard computer that mimics the responses of a skilled human pilot. This makes the AI-1 Smart Shuttle similar in many respects to the in-atmosphere drones commonly used today.
In addition to being completely automated, the AI-1 Smart Shuttle is also designed to be completely reusable. Unlike the vast majority of modern spacecraft, our design eliminates the need to eject large portions of the vehicle on its way in or on its way out of the atmosphere. This means that the vehicle is both more cost-efficient than its predecessors and is capable of being reused multiple times over the course of its life. This innovation should make the commercial space market more accessible, as it will make the transportation of people and materials to and from space significantly more feasible.
Taking off from a runway is a concept that hasn't been discussed very frequently in the aerospace industry. People like to stick with the belief around vertical launch that it works, so why bother changing it? Taking off from a runway does present a few challenges, however. The current space shuttle has wings with a very low aspect ratio, and thus they provide very little lift. This is not an issue, as the current space shuttle is used simply for landing and for descent, rather than for gaining altitude. And also, it is entering the atmosphere at a very high velocity. In order to effectively take off from a runway, we will be using a vehicle with a sleeker profile to minimize drag while maximizing lift, and strong jet engines will be used to achieve a high velocity at a very quick rate.
For creating a landing sensor on the runway, we can use the image registration. Image registration is existing technology that a system uses only vision to land on an unmanned aerial vehicle on a runway. The system estimates the relative location on a runway, creating an image by performing image registration against stack of images. Traditionally, UAV relies on GPS receiver for navigation and a solid-state inertial sensors for control. Our system would use a color video as an alternative sensor choice because they are light, inexpensive, and easy to use. Camera itself would function such as a target recognition or surveillance. For a successful and a safe landing approach, the UAV would have to descend at a constant angle, point in the direction of the runway, and touch down with the wings level. Our method is to steer the UAV towards the runway and maintain these requirements by using visual information with camera projection.
Though unmanned vehicles are hardly uncommon amongst in-atmosphere aircraft, the AI-1 Smart Shuttle is unique in that it is an unmanned craft capable of leaving the atmosphere and successfully returning without any human control. Mankind has sent unmanned craft into space before, such as Sputnik and the Hubble telescope, but these are not designed to be reused. They are sent to space where they stay. AI-1 is meant to leave Earth, come back safely, then repeat the process over and over again.
As has been stated multiple times throughout this presentation, taking off on a runway is not a common use for spacecraft. By launching off a runway, we will be breaking into new territory for the aerospace industry. This will allow for more reusability and the capability to launch spacecraft from a larger number of sites.
This concludes our presentation on Intelligence Incorporated's AI-1 Smart Shuttle, a truly innovative spacecraft that will revolutionize the field of artificial intelligence, aerospace, and the takeoff and landing of aero vehicles. Any questions?